As urban planners seek better and cleaner ways of getting people from A to B and back again, rapid transit systems continue to be the solution to their problem. Rapid transit is highly efficient and environment-friendly. There are many forms available for different urban demands, but regardless of type, these transit systems are expensive to build and to operate. So how do you improve both performance and productivity? The answer lies in increasing the flow of passengers, improving the service reliability, and reducing operating costs while providing the highest level of safety. It is the purpose of this program to introduce you to the system that meets those demands. It's the Seltrac Automatic Train Control System, designed and manufactured by Alcatel. The Seltrac system is proven and tested by years of service in major cities worldwide. It is the most advanced and refined system of automatic train control in the world, and we'd like to show you why. First, let's take a brief look at the limitations conventional train control systems have in trying to meet the demands of modern urban transit. Conventional systems of train control and signaling are based on the fixed block principle. Under this principle, the track is divided into sections or blocks of a fixed length. We'll use two trains to illustrate. The first train, or the leading train, heads along the guideway with the second train following. Under the fixed block principle, to enforce minimum safe separation between the two trains, the following train must never come closer than a predetermined fixed distance from the leading train. A fixed minimum number of track blocks must always separate them. These fixed blocks are based on fixed train parameters such as maximum speed, maximum weight, and minimum braking capability. Regardless of whether the trains are traveling at top speed or at a crawl, this distance is fixed. To meet the current demand of shorter headways for greater passenger volume, a system operating under the fixed block principle would require much shorter and more numerous blocks, which in turn would require costly wayside changes. Modern urban transit requires a train control system with the flexibility to handle changes in service demands as well as changes in equipment, a system capable of high passenger volumes but with minimum wayside equipment. Seltrac train control is based on a highly advanced method of achieving safe train separation. Under this more flexible block principle, minimum safe separation between trains is enforced not by fixed blocks of track, but by elastic blocks that lengthen and shorten relative to the dynamics of the trains involved. Again, we'll use two trains to illustrate, but now the trains and track are outfitted with the Seltrac system. Each train has an onboard computer, and wayside equipment facilitates automatic and continuous two-way communication between the trains and a control center. As the two trains head along the guideway, the Seltrac system components are continuously recalculating and enforcing the minimum safe distance between them, which creates the moving block that separates them. Our computer technology is highly advanced and exceedingly safe. To ensure vitality, all the safety-related system components are checked redundant. This means we have multiple computer units doing precisely the same task with the results being continuously compared. Let's have a closer look at the operational infrastructure of the Seltrac train control system. The Seltrac system operates under three levels of control: the management level, the operations level, and the activation level. The management level is called the System Management Center, or SMC. It consists of a number of computer workstations connected together on a local area network. From here, central operators supervise automatic train operations for the entire system. The SMC provides major system management features such as automatically assigning routes for trains, manually assigning routes in response to abnormal requirements such as bypassing closed track sections, and automatically regulating the speed and dwell times of trains in the system to maintain schedules and manage junctions. At the operations level is the Vehicle Control Center, or VCC. The VCC is the tactical workhorse of the Seltrac control system. It is primarily responsible for safe, efficient train separation. The VCC is a triple-checked redundant mini-computer complex. The VCC cyclically monitors the position, velocity, and travel direction of each train and, within a nominal cycle time of 1 second, sends data in the form of digital telegrams to the train's onboard computer. Each telegram includes an updated safe stopping point, the train's maximum permitted speed, the train's target speed at the end of its allowed travel distance, and braking characteristics based on track-specific grade profile. The third level of operation, the activation level, is made up of 3 subsystems. They are the inductive loop, the station controller, and the vehicle onboard controller. Let's look first at the inductive loop. The inductive loop cable is a two-way data link laid between the tracks to provide communication between the train and the VCC. Antennas mounted on the underside of the train communicate the signals between the loop and the onboard computer. This crucial exchange of data between the VCC and trains makes possible the most refined of the Seltrac features: the moving block principle, automatic train identification, automatic schedule control, precision station stopping, and automatic and continuous train location. The next subsystem in the activation level is the station controller. This subsystem is responsible for safe switch control. Switch movement requests are received from the VCC in response to switch control commands or route settings from the SMC. With the data the station controller receives from wayside axle counters, it constantly determines block occupancy status and provides for a system of positive switch controlling and route locking that is exceedingly safe. Throughout this segment, we've talked about a computer on board the train. This computer is the third part of the activation level. We call it the Vehicle Onboard Controller, or VOBC. The VOBC is a sophisticated computer unit which controls the train according to the commands received from the VCC. The VOBC sends train position, speed, and subsystem status back through the inductive loop to the VCC. Like all safety-related functions in Seltrac, this computer is checked redundant. This short introduction shows the basic concepts behind the Seltrac system. The advantages of such a system are numerous. With Seltrac train control, you can reduce headways, provide control of the complete speed profile, enforce supervision of temporary speed restrictions, provide bidirectional operation without added wayside hardware, provide wayside monitoring of vehicle systems, provide continuous train identification for routing, automatically regulate to schedules as well as other ATS functions. Seltrac, automatic train control, meeting the demands of urban planners and helping to create the future of urban transit today.